one of the big things about edge computing is changing this idea of your deployment topology from being a deploy time concern into a runtime concern.
This is DevOps Paradox, episode number 170, Running Containers at the Edge. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick.
Victor, you know I enjoy IoT. Not as much as I probably should, but I enjoy it. Why do you think I enjoy IoT?
Because Raspberry Pis that you have are more powerful than all your laptops combined.
That's probably true. That is actually not probably true. That is actually extremely true. Well, today we have on a guest with us. We have Dan Bartholomew on from Section. Dan, how are you doing today?
I'm very well, thank you.
And Dan is here to talk about running containers at the edge. And you're thinking, wait, I can run Docker on a Raspberry Pi? Dan, what really is the edge?
Darren, thank you. It's a deep question. And honestly, every conversation I have about edge starts off with, what is edge? And it's a complex question to answer. Like, we live on a spherical world. There are no corners anywhere. And if we go and talk to someone in hyperscale, they might say, hey, the edge is the network perimeter of the region that you're in. And certainly that was the take that network operators have, is the edge is the limitation of their of where their network boundary is. But what we're finding at the moment is that for many workloads, choosing a single hyperscale facility is a trade-off of performance and ease of management. For a lot of workloads, and people that come and talk to us, they say, hey, we're trying to build this low latency application. We deployed it in a single hyperscale region, and we couldn't get the performance that we needed. So we're going to re-architect their application so that we can run in multiple data centers. And oftentimes, these applications are not getting the performance that they need. And really what I'm talking about is network latency to end user devices, even when they're running in multiple hyperscale locations. So when Section talks about edge, what we talk about is a compute continuum. And what we believe the edge is a large network of places that can run your application, where the system is responsible for the placement of your application. And what that means is, under certain conditions, it might be best to run your application in a single hyperscaler. In other conditions, maybe multiple hyperscalers, or in another set of conditions, maybe we really want to be running this in hundreds of cities simultaneously. So trying to look at all of the potential compute locations from hyperscale down through to the ISP, and in a data-driven way, determine where my application should run is the way Section approaches edge.
So I'm guessing when you mentioned performance earlier, you were mostly referring within this context on performance induced by latency, right? Not that much compute power, right? Like memory, CPU, and things like that, right?
Yes. Yeah, very, very much so. Yeah. If you kind of cast back through the history of what edge is, it would be a valid argument to say that content delivery networking was the first incarnation of edge. And really the problem that CDN was solving was that pushing all the traffic back to my origin introduces too much latency. Now, by moving some of the content, the static content, closer to the user, we can improve overall application experience. However, it's done in a very kind of dumb way. So really, what people are looking for at the moment is to do more smarter things in that distributed footprint so that they can not only reduce latency of images and CSS files, but also the application execution itself.
There are obvious benefits of running something as close to a user as possible. I mean, depends, of course, on the type of the workload. I'm guessing gaming, like I play a lot of Stadia, right? That depends on how close I am. But my question is, does that mean that we should try to move whole systems close to the user or part of them? Because, there is an application that can be close to me, but it needs to talk with the database that is on, 5,000 kilometers away. And then, is there a special type of application that benefits from that more than others?
Certainly, application design matters in these things. We have running in our platform a wide variety of different workloads. For example, someone running a website on our platform, they built a Node.js application and they've shrink wrapped it into a container. And instead of running that in a hyperscaler, they've submitted those containers to Section. And this Node.js container that they run in our platform, it does all of the website rendering for this e-commerce website. Now, it obviously needs data sources like a product catalog and some state management for controlling people's cart contents. And then finally, it needs like a ledger style database where it can submit orders and then hook that up into all their back office systems for their customer success team, customer support team, but also their warehouse for dispatching things. So the application that they run at the edge, it simply does the website rendering part of that. And when it needs to fetch data, it actually fetches that through a write-through cache that also runs in the edge. And the benefits that gives developers building on our platform is that their Node.js container is actually being dynamically repositioned at different parts of the internet, depending on the traffic sources. So when Section looks to run things at edge, there are specific application components that are easy to lift and shift out of hyperscale cloud, but not everything. And probably the biggest challenge there is in relational and ledger style databases, where people are looking for certain types of basically acidity around how their database transactions are behaving. It is a really complicated question because if you take a single hyperscaler and say, okay, I'm going to run in many of your regions, you can get some predictability around what are the hard disks going to behave like? What kind of IOPS am I going to get out of them? What kind of reliability am I going to get out of it? But when you start to expand from like tens of hyperscale locations into high tens and hundreds of different locations, you get a wide variety of hardware characteristics. And some of those are suitable for running a MySQL database. And some of these facilities have magnetic disks. And if you were expecting any kind of database performance out of them, you'd be severely disappointed. So it's not an easy question to answer.
Thinking aloud, if latency is one of the main motivations, right? Then I would guess that some sort of serverless functions wouldn't be a fit, because whatever you would win in latency, you would lose in startup time, right? So then the question would be, do we need some kind of predictability model that will predict where the next group of users will be, in a way, right? Kind of, you need, in a way, you need to start application in advance before I actually request it, right? If the latency is an issue. But you need to guess where I'm going to be. And when I say I don't mean literally one person, but...
Yeah. There's a lot to unpack in that question. So here, distributed serverless offerings are becoming commonplace in the market. You can see most CDN vendors are augmenting their product offering with some type of distributed serverless model, which is, if you go and investigate them, they will talk about incredible cold start times on serverless functions. Now, Section has this model differently. Because Section is a container platform, not a serverless platform, we do exactly as you suggested. Containers need to be running there ahead of time in most cases. And so what somebody building a platform like Section would need to do would be to make some choices. Do you want to leave the containers running there all the time? Or do you want to do some kind of predictive analysis to say, hey, it's 6 a.m. in New York, people are going to be coming online. Let's start to prepare for this work. There's also like an adjacent question here that came to my mind as you asked that, which was, yes, containers need to be there ahead of time to avoid cold startup issues. But then there's also a secondary piece to this, which is if you're deploying containers into a smaller facility where you don't have the advantages of the infinite scale that you do inside a hyperscaler, what do you do if you're getting so much traffic that your containers are overwhelmed with the traffic? When we place a container into the network, we have a look at historical modeling and we say, yeah, okay, we know it's going to be worthwhile to run in New York. Let's go and start the containers, make sure they're healthy, and then we'll go and update internet routing so that we can actually steer packets towards those containers. And then while that's running, we're constantly monitoring the behavior of the containers to say, hey, we're actually hitting a threshold here where we're unable to meet the demands of these users in this facility. So then we need to start to peel off certain users and send them to the second best place and then the third best place, depending on how that works.
So what are those machines that you are, for example, having? I mean, I'm guessing, they're not hyperscalers. Where are they? What are they?
When Section was born, we were bootstrapped by myself and my co-founder. And so we didn't want to do any kind of capital expenditure-based rollout. So Section's business works by aggregating many companies together into what we call a composable edge cloud. And so we go and work with vendors like the hyperscalers. So we'll happily use hyperscale facilities when we find them to be most appropriate. But then we're also have a good relationship with Lumen, which is a tier 1 ISP. And what that means is we've got access to compute that is deep in the backbone of the internet, being a tier 1 service provider. But then other places that we like to run are in internet exchanges. So from time to time, we'll run containers in internet exchanges like Equinix. And where there is the localized compute weakness, we'll go and work with local providers that probably would fall into a category of co-location services. Kind of every major city has several vendors who work in co-location. And so we'll go and work with localized vendors to say, hey, how do I get into Perth, Australia? Because the hyperscalers aren't there and there's a market that needs to be serviced there. So the computers that we use range through bare metal, in some cases through to VMs.
And how does that look like from user perspective? Is it something as simple as here's my container image, go figure it out? Or any step above that or below?
Yeah, that is exactly the goal that we've been working towards. Distributed computing has a unique set of challenges in both operations and also in application design. When an application is built reasonably well and has tiers with ephemeral states, these types of applications tend to transfer well over into a distributed clusterless kind of environment. But the way that we present section to a developer or an engineer is that we have a Kubernetes API compliant API. And what that means is every dev tool that you can think of, from kubectl through Helm, developers are able to use those tools to interface with Sections API. So it's a kind of a low skill bar to actually learn how to use Section. But what happens there is when someone submits a YAML into Section, like a standard deployment YAML, Section will have a look at it and it will say, I'm going to place this in the network somewhere so that we could start to read traffic signals. And after we read some traffic signals, then we will do some optimization work to say, hey, our first guess was, hey, can you run my container in San Francisco? But then Section said, actually, did you know that the majority of your user base is in Australia and Southeast Asia? And so it will dynamically adjust the shape of the network based on that. That happens largely automatically. However, there's very good reasons to provide how to steer those decisions. For example, you might say, I want you to run my container everywhere you possibly can, and I don't care about the cost. And that would allow Section to run it in hundreds of locations.
Hey man, you need to tell me the company that says that, because I want to work there.
Yeah.
I don't care about the cost.
And so you're kind of like, that's an extreme end of that spectrum, where but running in one location like a hyperscaler is the other extreme of that spectrum. And really what we want to do for each application workload and each company's budget is find out where is the sweet spot on this spectrum of run in hundreds or run in one. And so we give, by submitting different config maps into Section via the Kubernetes API, our technology that we have in there, we call the Adaptive Edge Engine. And what its job is to do is to look at the traffic profiles, look at the workload, look at the network, and look at the developer's desires and try and make the best fit for that. And continuously remake that decision. In a lot of multi-cluster Kubernetes projects that you might see out in the Cloud Native Foundation landscape or on GitHub, a lot of these placement decisions about where do you want to place your containers on multiple clusters are deploy time concerns. They're not runtime concerns. And one of the big things about edge computing is changing this idea of your deployment topology from being a deploy time concern into a runtime concern, and letting data and orchestration do the magic for you.
Now, assuming that you're in the hyperscalers, the tier ones, we talked about, okay, it's easy to get effectively the ephemeral, the stateless stuff out, as close to the people as possible. But what about those data stores? Because those data stores, the source of truth data stores, not a replicated version of it. I imagine since we're in the hyperscalers or we're on tier ones, the number of jumps we've got to make back to a system of record is pretty minimized versus us trying to home roll our own edge implementation and then jumping back to a hyperscaler where our database is.
Yeah. I think that's a good way to describe it, Darren. There are a lot of different models for how you can address this problem. And it really comes down to the type of workload that you have there. For example, Victor, you mentioned Stadia earlier. Now, game streaming is really susceptible to poor user experience through jitter and packet loss in the network. So if we can decrease the scope of where that packet loss is occurring and try and get onto really high quality paths rather than just the general consumer grade internet from these edge locations back to these hyperscale databases or hyperscale facilities, we can dramatically improve user experience. But Darren, the same can be said for applications that need data stores that run in centralized locations. So if I've got this great Oracle database running in Amazon Sydney, and then I have my application scattered around, then kind of two things have happened here. What I've done is instead of allowing the user to application, the lag of the communication to be controlled by the ISP, if I move my application out towards the users, then I actually gain more control of my application in that I can write my code in so that I can construct the calls back to base in a different way. But I think, Darren, one of the things that's interesting to think about there is that a lot of applications are designed where the developer is thinking that the database is on the local LAN. And therefore, they will create systems, create web pages that make a lot of database calls. And if you have this assumption that your application and your database are so close together that there is no cost to building a very chatty application, that is a different type of application that can fully utilize the benefits of Edge. One of the things that application developers need to think about as they get these benefits of being at Edge is that middle mile needs control. Whereas before you didn't have control, now you have control of it, and you need to think about how are you going to use it.
I mean, what you were just explaining was classical client server. You had fat client, database on the same LAN, click all day long, doesn't matter. Then we went web, which basically meant we pushed everything back into the data center, and we were dependent upon people and their pipes getting to our servers. But now, if we're moving things further out to the edge, that distance between whatever the centralized data store is, and it can be numerous things, you're right. If that's chatty, you're going to be toast. Now, here's a question. You've been saying Kubernetes compliant APIs. You didn't say it that way, but I'll use my words. So it sounds like you're running multiple Kubernetes clusters. And in saying that, I'm going to magic hand wave. You have a single Terraform plan that has spun up all of your Kubernetes clusters. So what's so hard about that?
That is a really good way to do it, actually. And that is what we do. So for every provider that we have a set of Terraforms that will go and spin up compute primitives and lay down a vanilla Kubernetes cluster. So each individual facility that we have has one or more Kubernetes clusters in it.
Okay, let me ask this question because you said vanilla Kubernetes. Are you really running upstream, or are you doing a distribution of somebody's?
No, it's just the vanilla Kubernetes. It's not someone else's distro. Now, what Section has created on top of that is in our control plane. What we have is an essential facility that runs it runs a Kubernetes cluster, and inside that Kubernetes cluster are many instances of the Kube API. And so the Kubernetes API pod, we run hundreds of these inside a single Kubernetes cluster. And each customer workload has a dedicated Kubernetes API there. And that gets backed typically in a normal Kubernetes cluster, that would get backed by etcd. But in Sections world, that API backs onto a SQL database, which is then basically the metadata state from which Section can say, hey, the customer asked us to run this container. Let's go and make some decisions about which Kubernetes cluster are we going to signal. And we'll go and tell our remote Kubernetes cluster, hey, can you please run this container? And then we'll keep interrogating that remote cluster to get its state and pull it back into this central kind of virtualized cluster. And so when you say kubectl get pods, it'll say, yeah, okay, here are all your pods running. And typically, if you ran that against a single cluster, you would see the node name of the computer that it was running on. But in Sections abstraction of that, when you say kubectl get pods, it will say, hey, I'm running in Amazon, Ohio. I'm running in DigitalOcean, New York. I'm going to run in Lumen to get access to Denver. And I'm going to run in Equinix to get access to Amsterdam. And I could do things there, and I could say, hey, let's say I want to log into that Amsterdam container. I can simply say, hey, kubectl exec to the Amsterdam container and bring up a shell directly in Amsterdam using exactly the same operational techniques that you would use for development environment or a single cluster.
So it's like control plane of control planes.
Yes.
Type of approach, right? You're using one Kubernetes cluster to manage workloads spread across X clusters, right?
That's exactly really cool. Right. It is actually really fun to use. When we started working on this, and Mesos and Kubernetes were kind of looking pretty similar, and then I finally got containers working in Mesos, so I was just shocked because that was hard. And then in Kubernetes, I got them working. It just feels so natural to me to build YAML, supply it, and work with a single Kubernetes cluster in that way. But when you're trying to run tens or hundreds of different locations, you don't want to change the operational paradigm for people who you're trying to convince to move these applications over here. So having the lowest possible barrier to entry, which was all of your existing stuff just works, is really what the Section has tried to achieve.
I've got a weird implementation question. Do you act as the registry of record for all of the images? Or is that the preferred method? Or how does an image end up within the I was going to say the four walls, but everything's a sphere and nothing is flat Earth. So what is the proper way to manage that?
Yeah, it really comes down, fantastic question, by the way, because it comes down to who has responsibility for availability here. And so let's say, for example, you build a great container and you put it on Docker. And you tell me, hey, go and run this in 10 different data centers. I've written a YAML. Here it is. Kubectl, apply, my cool deployment. And what happens is Section will go and signal all the remote clusters, and they will go and do a direct download from Docker. Now, that would be fine if that's a public image. You could supply some image pool credentials if you've written, some super secret container that's got all your proprietary business logic in it. And then each of those remote clusters would authenticate into your registry and be able to download the container. Now, the availability question comes in here of what should the edge do if your registry is unavailable? Should section have used some read-through cache to try and grab a copy of your image so that it could keep it running? And there isn't a single answer that's always going to be right there. So at the moment, what happens is each individual cluster will download the image from the registry that you have supplied in your YAML file. Section could gain availability advantages and possibly some internal cost advantages if we had a read-through cache, meaning that on the first time we go and pull from your registry, we'll take a copy of it and try and use the copy if the origin registry is unavailable.
Seems like that'd be a logical thing for a company that's doing distributed compute, is to do caching. Sorry, it's a bit of a joke. I'm ribbing you. I don't know you well enough to poke at you that much right now.
I'll just copy.
No, it seems like that would be cool, or at least if it was up to the customer to say, "Hey, look, this isn't super secret. Just go ahead and keep a copy of it locally. I'm following good tagging hygiene. I'm not going to reuse the tag. I'm doing the right things." And then, maybe make that an extra cost of, "Hey, we'll manage it because you're now going to, we can now guarantee better availability."
Yeah.
Whatever. I don't know. I'm trying to product for you right now, and that's a bad thing.
That I appreciate it. Like having thought about this a lot, there isn't a single answer. And
there are multiple answers. The question is, how much do you want to turn it into a product within Section?
Yeah. And Section would like to solve everybody's problems, but we have to pick our battles here. In terms of Section's priorities, it is security, availability, performance. And that is always the sequence of things that we will make design decisions about. The challenge with image storage, it is actually kind of deep, right? If you're running a multi-tenanted Kubernetes cluster, even just one cluster, the kubelet will save the Docker images on the local hard disk. And if I say, "Hey, one customer in namespace A, you have successfully downloaded this image and it's now on the disk of that node," customer B, if they knew the name, they could come and just start running that image. And you go read the Kubernetes documentation, there's a whole bunch of things you need to do on it. In fact, you need to force kubelet to do an authentication check every time it wants to start using that image. So, Darren, I'm getting distracted by your question there. It's a fun one.
It's fine, and that's a lot of people listening. That's the kind of problems that a lot of them have to solve. But thinking through this, you're running. You have your cluster of clusters, and obviously that took more than a weekend to get working correctly. What do you say to people that are just now starting to think, well, I just need to run my application in multiple clusters around the world, and I'll just spin up a bunch of different clusters and make my images available? What are they not thinking about? And let's assume for a moment that it's not multi-tenant. Let's just say it's a company,
Sure.
It's company X, and it's their stuff.
Yeah.
What aren't they thinking about?
Yeah, there is a significant amount of day two operations that goes on to do that. Right now, you could log into Amazon and go and make 5 EKS instances. And then you could go and get something off GitHub that will synchronize those 5 clusters. And you could say, "Hey, here is my YAML. make sure all of those clusters have that YAML running right now. But what we've found in talking with a lot of enterprise customers about that is people that have done that find that they start to tap out at somewhere around 8 to 15 locations globally because the amount of data operations builds up on it. For example, even doing Kubernetes upgrading and patching on those 10 clusters is not free. Then trying to work out, okay, I've got these 5 Amazon clusters and I've got some at version 120 and I've got some at version 121. How are my developers going to deal with these version differences between all these clusters? So there's a significant amount of operational complexity that is largely what Section builds into its SaaS offering to hide from customers, to just say, hey, build containers, tell us how you want them run, not where you want them run. And we will go about finding the right place in this compute continuum to make that happen. And there is further to all of that. The bigger you go, and by that I mean more locations, the more traffic routing issues you're going to be subject to. DNS can work fine with a smaller number of locations. But when you want to start to get very granular about which cities are your containers running, DNS's ability to control individual users starts to fall down because it's really the ISP's DNS that has the routing control. So, Darren, I would encourage people to go and spin up multiple clusters and go and experience the benefits of distribution and having multiple instances. And if they've got questions about how they can make that scale, I'd love to answer you.
So, Victor, did you have anything else?
No, I think that we could continue for a couple of hours, but no.
That's what I'm thinking. We may have to have Dan back on once we I want to play with Section a little bit. Because there's rough competitors in the market space. I'm saying rough because I'm thinking render, fly, something to where I just give them a container, right? There are spaces there. But it sounds like you're going at it in a little bit different angle, at least from a business perspective. Those companies that I just listed seem to be targeting the bottom of the food chain developers or the small businesses or whatever. It seems like Section is targeting more the enterprises. Am I incorrect in that guess?
But that's a really good way to look at it. And if additional concerns we have to deal with in order to hit that market segment are like we have a significant compliance operation. Some of the vendors that you mentioned there don't have service level agreements, and enterprise has a different set of expectations for what they need to run these things.
Okay, well, all of Dan's information will be down in the show notes. Dan, thanks for being with us today.
I appreciate it, guys. Thank you very much for your time.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.